Perfect. Sweet. So I think this presentation is going to have more questions than answers. That's primarily where my head's at. And I just kind of wanted to bring this up to the larger application security world in general. So that's what we're going to walk through here. My background. That's my son, by the way, Max, in the picture with me. I am a staff manager at GitHub. I've been there for a little over 4 years, and for basically 3-ish years, I focus primarily on our testing, so source code dynamic testing type stuff. So that was my primary focus. And now I manage 2 teams that are focused again on adversarial activities, red team, and assessment. Why I bring this up is where I'm coming from. This presentation is from the perspective of an internal tester with an adversarial focus, and not necessarily so much a consultant, testing methodology, I should say. So yeah, I've written code, I've defended code, I've been a trainer, a speaker, a manager, a CTO, et cetera, et cetera. I think what's relevant though is that I've been doing things with web apps and programming for easily 16 years, and security for approaching about 14 years of that. So it's safe to say that while I'm not super old or, been around forever, I've been around long enough to see some pretty monumental changes in both web applications and their architecture, as well as how we go about testing them. So that's kind of the focus of today. Also, I just wanted to plug, I've got a podcast, Absolute AppSec. It's all things AppSec. Seth Law, who is also speaking at this conference, is my co-host on that. All right, so technology, where did it start? Early 2000s, when I was doing things, web servers basically pointed to a directory. And when you sent a request, your HTTP path net URL pretty much pointed to a directory and file location, right? That's obviously there's variances there, but that's kind of the basic gist. And you might have a database to store and update some data. Not super complex. Testing was, we're going to talk about that, but testing wasn't super hard in a configuration like this. Sometimes people get fancy and add like a load balancer or something, but this is kind of the generic architecture you would see. And now it obviously has changed pretty dramatically. Like the scope of the things we're trying to do with a web app and the complexity has greatly increased. Along with that has come a need for handling that complexity in a performant way. So you see, we've got this architecture here where maybe we have some load balancers. Maybe some of our assets that are static assets are hosted on a CDN, again, for performance. We might have like a monolith we're trying to break out of or keep around, but back with various microservices that handle the added complexity of whatever that monolith was originally built to handle. And yeah, just in general, you might have like this DevOps type technology in memory databases like Redis or Memcache, maybe a pipeline like Kafka. But things are significantly more complex. And that is, like I said, it came out of a need. We're doing harder things with applications. This is also another example of some architecture you might see. I just used AWS in this example, but you might have like tying together various services within AWS to make things work, right? So an application as we see it, or a URL as we see it, or a host as we see it, is not necessarily just one piece of body of, here's a web server, here's some files and a directory structure, and like you're off to the races. In fact, it's more, hey, you're going to hit this thing that's going to then redirect traffic to one of these various components. It'll pull in from various resources. And it just makes things a bit more complex to conceptualize as well as test. And so what was our testing like, when I started or earlier on in the 2000s? Well, there were like 2 primary static analysis tools, Ounce and Fortify, from a commercial standpoint anyways, that you would run your code base against. Pretty easy. You get a code for an app, and that's just, that code represents that application. You run it through the source code analysis. Maybe you'd use something like web inspect. Maybe you'd point it at a URL, maybe do a simple login macro, and then it's off to the races fuzzing, right? Testing was fairly easy. Maybe use Fiddler or Burp. But again, those tools back then were super basic, and that's just how testing was performed. Now what we're seeing is an explosion of sort of the testing tooling and ways people are trying to attack this in a pretty bespoke manner. Some of the interesting things I think we're seeing are like SemGrep and CodeQL, right? We're seeing internal team members, consultants, just anyone doing some level of code analysis or some level of security testing, writing custom queries. And why are they doing that? They're doing that because the proliferation of languages and web frameworks and libraries to support the complex things that applications need to do nowadays, it makes it very hard to get one tool that can handle all of those things. It's nearly impossible. What makes more sense is to write your own custom queries that match up with the patterns of risk you're looking for. And so we see like SemGrep, CodeQL in use. We might see Sneak, Dependabot, looking at those libraries to make sure that they don't match up. They're not outdated and don't have CVEs. Still using Burp, but I think what's interesting about something like a Burp Suite, I'm just to use that as an example, is that the functionality within Burp, but more importantly, the extensions to those tools and the way people are using them and the way they're really just leveraging their ability to make requests and handle, data and do this with speed and scale. It's requiring a lot of customization. And again, I guess what I'm trying to say is all of the testing that I'm seeing now requires more and more work on the side of a tester to sort of customize their approach. And so what are the challenges that we're faced with right now? Well, one thing I think that's really top of mind for me is testing an individual component, or you could think of that as a service. You could think of that as a web service. You could think of that as any piece that comprises an application. Testing that in isolation with like either code review or dynamic analysis, it's not really as feasible as it once was. It doesn't give you the full picture. I think there are certain classes of vulnerabilities that are easier found dynamically or statically, depending on the category of vulnerability. And I'll talk about that in a second. Lack of the out-of-the-box tooling. Like there isn't a whole lot of tooling that just comes out and you're just like ready to run it and it just hits at all of your needs. That's a difficult challenge. Again, many different languages, many different frameworks, many different components. How are you supposed to get 1, 2, 3, 10 tools that all kind of just handle this seamlessly? Very difficult challenge. The velocity of development makes, so if you're internal, you're probably doing a lot of like pull request reviews. It's not always going to be like, hey, I'm going to review an entire service. It might be, I'm going to review an ad hoc piece of code that lacks, it lacks some context. And obviously, if I don't take the bigger architecture into account, then this PR out of context may not make sense. Now, try doing that with a small team, which is most AppSec teams, and then doing that at scale with a quick development velocity. It's very difficult, right? So what are the possible outcomes of these challenges? I think testers will have to continue to utilize more custom queries, which brings into question, what is the skill set of a tester? I think it's a mix of security knowledge with pretty good engineering skills. And so then there's a question that I start to think about is how much of this is AppSec testers doing this work and how much of this are, security minded engineers. And I think we've all heard the term security champions and all of that over and over again. But I do think in terms of scalability, it's interesting to ponder, how are we going to be writing these queries and who's going to be responsible for that work in the future? And then, so in terms of trying to review every PR or, review every small code change, I think what we're looking for and what we've seen, this is not anything new, is more automation signaling when it's important for a manual review to occur. I think aligning the category of vulnerability with the type of testing is one of the things that's top of mind for me. It's probably the biggest thing at the top of my mind is, just taking a step back for a moment. What we've seen with these service-oriented architectures and these distributed systems are mismatches between what is happening on the front end and the back end. So this introduces a few interesting problems. Jim ended his last talk discussing SSRF. SSRF is super prevalent because we are often using user-supplied input to determine which service we're going to reach out to. So it absolutely is a problem that is just continuing to grow. I think other things we've seen are like web cache poisoning. We've seen HTTP smuggling from James Kettle. We've seen weird authorization bugs that have cropped up. When I say we, I just mean the community at large. Authorization issues crop up, where there is an assumption that the front end did certain things. The front end's parsing data, repackaging that data and forwarding it on to the back end. And the back end has certain expectations of the front end. And sometimes those things mismatch and lead to some significant logic flaws. But in any case, I think the easiest way to determine those types of vulnerabilities, honestly, is a runtime fuzzing. Whereas something like, maybe insecure direct object reference or vanilla injection, those things are easier in a source code review. And so it becomes a mixture of like, what are we trying to test? How are we trying to test efficiently? And I think the last point I want to talk about here is just sort of the risk-based approach. And I don't mean the risk-based, obviously with Go SDL and a focus on like tools like Go SDL and a focus on security reviews, we've started to identify, I think riskier services. And I'm not talking about testing in that way, right? I'm not talking about identifying which services need to be tested. I'm actually talking about which components of that service need to be tested, right? So if this service's main function is to handle data, then I'm going to be looking at how it's handling data. Like, is it working with an in-memory database? Is it using NoSQL, or do I have to worry about NoSQL injection or tampering with the set get keys with an in-memory database? What are my biggest risks to that application? And then with the short amount of time and the velocity of development, focus only on those parts. Is this something we think makes sense? So my open questions as I close up here with 2 minutes left to the community is, and this is going to sound weird, I'm sure, but how critical is testing, right? How big of a part of our overall SDL, if you're an internal defender, do you find testing to be? It's interesting. I've talked to a few folks in what I would classify as Silicon Valley type organizations, and I think they're moving more towards becoming security engineers, writing things like paved paths and libraries and tooling and just doing more engineering work in a preventative way versus like testing. If testing isn't our focus, then what would be? Is it more investment in paved paths? Is it more investment in bug bounty programs? Or alternatively, the last bullet point, maybe testing is still considered a key component of the SDL. I have a vested interest in doing testing since that's my primary job. And if it is considered a key component of the SDL, what are our options? How do we bring our testing into the new era of this complexity that blends infrastructure with code and does it at a high velocity with varying frameworks and languages, and really a lack of out-of-the-box tooling to address that? So I think those are some of my open questions as I look to this new year. For me personally, and I'm sure for a lot of you out there, I'm going to be focused on, how do we bring testing into the modern era? That's my speech in a nutshell, I suppose. So like I said, not too much to end with with answers, and just really ending with more questions and some interesting observations. For my contact on Twitter, you can reach me there at cktricky. I check DMs once in a while. I think it's better if you email me, cktricky@gmail.com. Happy to discuss more of these ideas, but that's my time. Thank you.
Thank you very much, Ken. That was amazing. We've got a couple of questions here, actually. So the first one is, are any of these testing tools integrated in a pipeline? So any of the tools that you mentioned there?
Yeah, absolutely. I mean, I think, I work for GitHub, right? So obviously Dependabot's a pretty big part of what we do. And then for code scanning, we leverage CodeQL, but I also use SemGrep, and I use SemGrep not so much in a pipeline yet. That is something I would like to do. But absolutely, we hook tooling into our CI/CD pipeline. Yes.
Awesome. And we got just one more. So this is from Magno. What are some of the approaches you recommend for smaller teams to scale in their AppSec programs?
So I think if I had to put it into a nutshell, I would say probably define paved paths and checklists for what things like requirements you want. So if you know which technologies you prefer for folks to use and they're comfortable using internally, probably build some secure coding recommendation checklists and guides so that at least the basic security hygiene stuff is caught. Also introduce a system where there's at least heads up on the release process. For us, we're not a blocker. We don't need to test. Unless we say we're a blocker explicitly, we're not a blocker, and things ship to production, and we review as we can, and we do that with a risk-based focus. So I think prioritizing what you're reviewing, putting into safeguards like paved paths, putting in requirements helps a lot. And yeah, that's like sort of the basics. And then there's other stuff around hardening your infrastructure or using templates if you're using cloud security. So there's a bunch of little things we could talk about as well.
Amazing. What an amazing session. Also, we've had a few comments about your background. I think everyone's very jealous of the wall behind you.
Thank you.
Great things. I almost want to make you a little bigger there, and then we can all just have a quick look. You've got quite a lot going on. I love it.
Thank you so much. Yeah, it's all the things I've enjoyed and collected over the years. I've tried to make my office enjoyable.
Absolutely love it. Cool. Well, thank you so much again, Ken, and for anyone obviously watching, feel free to pop any more questions in the chat on Hopin or within the DevSecCon Slack community. But again, thanks so much, Ken, and hopefully we'll see you soon.
Thank you.